Welcome back. In the previous video, we walked through the installation process for R and RStudio. Now, we will discuss the data types in R. In programming languages, we usually need variables to store information. The type of the variable is purely based on the kind of information it holds. If it is an integer, then the variable has an integer data type. Variables are merely reserved memory locations at which values are stored. As soon as you create a variable, some memory space is allocated by the operating system. The amount of this space is based on the data type of a variable. For example, in R programming, a variable that holds an integer will reserve a memory of 4 bytes, while a character holding variable will reserve 1 byte. In programming languages like C, C++, and Java, variables are declared as data types. However, in Python and R, the variables are an object. Objects are nothing but a data structure having few attributes and methods, which are applied to its attributes. In this course, we will discuss various kinds of R objects, or data structures such as vectors, matrices, lists, data frames, factors, and arrays. Now, let's understand some of the basic data types on which the R objects are built. These are character, numeric, integer, complex, and logical. Characters can be letters, or a combination of letters enclosed by quotes. It can be alphabets, or numbers. Numbers that have a decimal value, or are fractions are considered to have a numeric data type. Numbers that do not contain decimal values are considered to have an integer data type. However, to create an integer data type, we have to explicitly use the as integer function, and pass the variable as an argument. The complex data type can store numbers, with an imaginary component such as values containing the imaginary number I. A variable that can have a value of true and false like a boolean is called a logical variable. In R programming, the very basic data types are R objects called vectors, which hold elements of different classes. The number of classes are not confined to the 6 data types, and we can combine elements of these data types to form data structures such as atomic vectors. An atomic vector is called such because it holds data of a single data type. The variables are assigned with R objects, and the data type of the R object becomes the data type of the variable. Variables provide us named storages that our programs can manipulate. A variable can be assigned values using leftward, rightward, and equal to operators. Let us first look at the character data type. We will define a variable to store the data, var1, and store hello world in it. And define var1. We can use the function class to find out the data type of a variable. As you can see, var1 has the character data type. We can also use the function type of for the same purpose. Coming to the numeric data type, we can define a new variable var2, which will hold the digits from 1 to 10. We can display the contents and the data type of var2 in a similar manner. Let's check the data type of var2 using the class and type of functions. If we want to convert this data to numeric, we can load this data to a new variable using as.numeric. Now, let's print var3. Now, if we check the class of var3, it will show numeric. Now, if we define a new variable specifically, as an integer, say 24L, it will be of an integer data type, as can be seen using the class and type of functions. Now, let's define a complex number using a new variable, var5. We can see that the data type outputted by the class function is complex. R supports complex data types, which are sets of all the complex numbers. The complex data type is to store numbers with an imaginary component such as the imaginary number I, or iota. These numbers are called complex values. Let's look at the logical operator using a new variable, which we will define as true. When we check the class of var6, it would show as logical. Similarly, we can use the typeof function